Happy Friday. We're going to go over both PTN questions, which are reviews of what we did the last 2 days, making a improper fraction into a mixed number. Here we have the picture, so we can draw out and write in our fractions here. I know I have 6 sixths here, 1, 2, 3, 4, 5, 6, and each shape is divided into 6 equal parts. 6 sixths here as well, and then I have 1, 2, 3, 4, 5 out of 6 shapes shaded in. Both of these are whole, represent one whole because every single part of the shape is shaded in. So I have 1, 2 whole numbers, and then my proper fraction I will add on to the end, 5, 6. 17, 6 is equivalent to 2 and 5, 6. When we just are given the improper fraction and we want to make a mixed number, I always draw my shapes just like above myself. Since the denominator is 3, each shape I draw is going to have 3 equal parts. I'm going to keep shading in until I have shaded in 8 parts, since that's my numerator, and then I'm going to stop and think about my mixed fraction, my mixed number. 1, 2, 3. Not at 8 yet, so I'm going to draw another box of 3. 4, 5, 6. Not there yet. 7, 8. Ooh, I'm there. Nice. Now I'm going to write 3/3 is this fraction, 3/3 is this fraction, and 2/3 is this fraction. My two whole numbers are the ones where the numerator and denominator are the same, and every part of the shape is shaded in. That's 1, 2. So that's going to be 2 as my mixed number, whole number. And then I have my proper fraction left over, 2/3. So 8/3 is equivalent to 2 and 2/3. Now we're going to shoot our shot putting mixed numbers and improper fractions onto number lines. Peace. Team, today we're going to talk about putting improper fractions on the number line. All proper fractions are between 0 and 1, but all improper fractions are greater than 1 whole. So when we have like a proper fraction, it's always between that 0 and 1, but the improper fractions are somewhere between this 1 and any number bigger than 1. So when we have fractions, that we can actually count them out based on their wholes. So looking at this one, number 1 asks to put all of these fractions into fourths. How we would do that is we would just go to each whole number, 0 to 1, and divide it into 4 parts by creating 3 lines. So I go 1, 2, 3, and I have 1, 2, 3, 4 parts. Then I have 1 to 2, and I would do the same thing. 1, 2, 3, 1, 2, 3. And I've now created each whole from 0 to 1, 1 to 2, and 2 to 3 into fourths. Right? I can do that because every fraction is just 1. So I've created just Kit Kat bars of 1. Looking at this example, now I have 9 fourths. This is an improper fraction because my numerator is bigger than my denominator. So I know this fraction is bigger than 1. And we've been putting fractions on number lines by creating from 0 to 1, like the number of parts in our denominator. Now we're going to do that in every single space from 0 to 1, from 1 to 2, and 2 to 3. So watch this. I'm going to create each one whole into fourths by creating 3 lines. 1, 2, 3. 1, 2, 3. 1, 2, 3. I've now created all of my fraction into fourths. And now I'm just going to shade in the number of fourths I have in my numerator. So I'm going to shade in 9 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now it's just exactly like what we've done before. I'm going to drop, put a dot, and plot 9 fourths. I made my fourths because each whole number from 0 to 1 is into 1, 2, 3, 4 parts. 1, 2, 3, 4 parts. 1, 2, 3, 4 parts. And I know that this is 9 fourths because I've shaded in 9 of those parts. For number 2, it's asking me to, or example 3, it's asking me to put 8/3 on the number line. So instead of making 4 equal parts between each whole number, I'm going to actually divide it into 3 equal parts by doing 2 lines. 1, 2, 1, 2, 1, 2, and 1, 2. And now I'm going to shade in 8 of those parts, since 8 is my numerator or the number on top. 1, 2, 3, 4, 5, 6, 7, 8. I stop at 8, drop and plot, and write 8/3 on my number line. Shoot your shot.